Guys, today we're on gravity. Gravity is going to be page 18. This is a review from what we did last week. So the first thing I want you to do is define gravity. It's an attractive force between two objects. And then when you think about two things that gravity depends on, that would be your mass and your weight, because the formula is mass times gravity equals weight. All right, and tell me why Earth has a stronger gravity than the moon. It has to do with its size. All right, use your formula, weight equals mass times gravity, to figure this one out. And then look at this, centripetal force. If you had an icy road, you would go straight off this way. Why is that? Because there's not enough friction to hold you in this circular pattern. All right, now I want you to flip over to the notes on work. All right, the notes on work are on page 23. Okay, work is a pretty simple concept. I want you to fill this in on yours. So work is done when a force acts on an object in the direction that it moves. Therefore, work is a force exerted over a distance. Okay, if there's no movement, you have no work done. All right, so the formula for work is work equals force times distance. Since force and distance are multiplied together, they go in the bottom and work goes in the top. Work is going to be measured in joules, force in newtons, and distance is going to be measured in meters. Okay? So machines. A machine is something that makes your life easier. It's a device that can change a force. So when changing a flat tire, you are the one who applies the handle or the force to the jack. The jack handle changes this force and applies a much stronger force to lift the car. Therefore, machines make work easier to do. They change the direction of the force needed, the size of the force, or the distance over which you apply the force. Just like a ramp makes it easier to push someone over a wheelchair. So work input and work output. The work input is done by you. The work output is done by the machine. And the one done by the machine is called the output force. And the one you do is called the input force, or your effort force. If you're pushing someone up a ramp, that is your effort distance. The distance for the machine to act over is the resistance distance. So that if you think about the height of the ramp from the ground, that would be the resistance distance. So machines multiply your force. That's why we use them. We use the jack because it multiplies your force. You would never lift the car on your own, but the jack can help you. So on the back of this paper, we're going to do some practice, okay? I want you to draw your triangle. The triangle is work goes in the top, is force times distance, okay? So draw your triangle. It says I lift something 30 newtons, that's my force, so 30 goes right here. 2 meters, that's my distance, 2 goes right here. 30 times 2 is 60, so my work is 60, and that's going to be in joules. Which of the following is having work done on it? Okay, so remember, a machine has to change the size, direction, or both. So a grocery bag, as you lift it up, that's helping. A crane moving dirt, that's helping. It's a force over a distance. A crate, as you push it, that's a force over a distance. But a person sitting on the bench is not. So suppose you want to calculate how much work it takes to lift a 160 Newton barbell. Besides the mass, what other information do you need? Well, you need to know the distance, or you need to know how much work was done. So we need to know how high it was lifted. We need to know this distance. So in the equation for work, F is the force and D is the distance over which it's applied. If you're in a car that's being pulled down a 56-meter path with a 12.5 newtons, let's put that in our triangle. Force is in right here, 12.5, and then 56 goes right here. So if you multiply 12.5 times 56, you get 700, and remember, work is in joules. Okay, a crane does the work of 13 13,500 joules. That goes in the top of my triangle wide so I can write it. 13,500. The force is 5,200. Remember, if one's on top of the other, we divide. So 13,500 divided by 5,200 equals 2.6, and this is our distance, meters. All right, I want you to try this one out on your own, okay? You have a 600 kilogram great white shark. It's being studied using motion sensors on the boat. The shark leisurely charges the cage and strikes it. Later, the shark returns for another run at the cage. This shark strikes with 12,800 newtons. So here's your force, and your mass really is not going to matter right this second. The shark traveled for 10 meters, force and distance, making its run. The cage can only withstand 124,500 newton meters of work before it breaks, should the man be worried. Okay, so see if you can figure out how we would find this answer and explain it. All right, have a wonderful day.